Assalamualaikum. My name is FARID HAKIMI bin KARIM. My metric number is B132310117. Today I would like to share about our project introduction. We have 5 project overview. First, project summary. Second, design highlight. 3, installation key points. 4, operation and control. And 5, maintenance approach. At the first, project summary. Central HVAC system for thermal comfort, air quality and energy efficiency, suitable for mixed-use retail and office space. 2, design highlight. Load calculation based on climate, materials, glazing and occupancy. System option, VAV, chill water and VRF or VRV. Zoning enables independent control per floor over unit. 3, installation key points. Quality installation of ductwork, chillers, AHUs, control, coordinate with electrical, plumbing and fire protection system. At last, noise control, vibration isolation and easy maintenance access. 4, operation and control. Smart system with monitoring and automation, user-friendly interface for efficient performance. And last, 5, project overview is maintenance approach. Routine, filter change, lubrication and inspection. Preventive, schedule checks, predictive, sensor-based analytics to prevent failures.
Assalamualaikum and hi to everyone. My name is Ahmad Nawawishah bin KURNADI. My number matrix is B1323100055. Okay. I will tell you about the objective of our project. The objective of our project is to ensure a comfortable, safe and energy efficient indoor climate for the building occupants and visitors while complying with the national and international standards for HVAC system. The project is to aim to produce a complete O&M manual that support efficient life cycle management. For our building is a shopping lot building. This is our flowchart for the project. We start from the find the building and the layout of the building, and then we select the HVAC system of the building, and then we do calculation using HAP software, and then after that we discuss about the safety precaution and ideas for improvement for the building. And then after that we documented the findings and the result.
Next topic, we will share about our building and system description. Building characteristic. Floors, we have ground, 3 floors with partial ventilated rooftop. Facades, extensive glazing, east and west facing. Usage, commercial, retail, store, administrative space. Estimate floor area, 2,400 to 3,000 square meter. HVAC system type chosen. As we can see, at the first component, VRF outdoor units. This purpose is provide heating or cooling to connected indoor unit. Second, ceiling cassette and duct units. It is because it can deliver conditioned air to zone. 3, AHU or air handling unit. Deliver air to maintain indoor air quality. 4, heat recovery ventilation or we call HRV is for energy conservation. Exhaust fans for toilet, pantry and food service area. And the last component for HVAC system type chosen is BMS integration. Its purpose for smart monitoring, alerts and analytics. That's all from me, and I pass to my next friend for presentation.
For broad installation activity, first we do a site survey and duct pipe routing assessment, and then we do a coordination with civil and electrical teams. Then we load calculation using HAP version 6.2 software. And last is we are drawing using Revit. For indoor unit installation, we are install bracket and mount cassettes, ducted units. Ensure correct elevation and drainage slope. And seal penetration with fire resistant material. For outdoor unit installation, we are mount off rooftop platform with anti-vibration mounts, provide weather protection enclosure, and maintain minimum clearance as per OEM manual. And for piping and cabling, we are run insulated refrigerant pipes and drain lines through vertical shaft. And we are installed control wiring and communication cable between unit and PMS. For ducting and ventilation, we are use GI ducts with 25 mm neutral insulation for cool air. We are install volume dampers and motorized dampers. And we are connect toilets and pantry to exhausts. Last is PMS and electrical work. we are using power supply to each unit from DB panels with MCB or ELCB. Commission temperature and motion sensor, and we are doing BMS integration. For the drawing, as you guys can see, this is the each part of the building, which is 3D view, east elevation, west elevation, south elevation, and north elevation. Okay, for floor plan, we will have 4 levels. The first one is ground floor, and first floor, second floor, and roof level. For ground floor level, as you can see, this is the ground floor. For first floor and second floor is the same, so we are using the one drawing for the 2 floor. And the roof floor, as you guys can see, we are in the picture. So, and as you guys can see, for each floor they do have same dimensions and so on. So yeah.
Next, I will tell you about the HAP calculation. In HVAC engineering, HAP is a hourly analysis program by carrier. It is used for detailed building load calculation and system sizing. This is the our project calculation for the building system loads in latent heat and sensible heat.
Hello, my name is Lojoyi and my metric number is B132310244. Today, I would like to talk about some critical safety precautions that must be followed across different work areas to ensure a safe working environment. First, rooftop work. When working on rooftops, it's essential to use fall protection PPE, personal protective equipment, and have safety railing installed to prevent accidental falls. Second, electrical work. For electrical jobs, always implement lockout and tag-out procedures and use insulated tools to avoid electric shock and ensure circuits are de-energized. Third, refrigerant handling. When dealing with refrigerants, use recovery units, leak detectors, and wear protective gloves to prevent exposure to harmful chemical substance. Fourth, ladder and scaffold use. Only certified personnel should operate on ladders and scaffolds, and they must be under proper supervision to minimize risk of falls or improper use. Lastly, fire safety. Finally, always keep fire extinguisher nearby, especially when performing tasks like welding. Use flame-proof materials to reduce fire hazards. These precautions are vital to protecting both workers and worksite. Now let's look at the routine maintenance schedule and checklist, which ensures all essential systems operate efficiently and safely. Starting with VRF unit. This requires coil cleaning, leak test, and refrigerant checks on a quarterly basis. This task is carried out by the HVAC technicians. For the AHU, air handling unit, regular filter changes and belt inspections are performed monthly by the maintenance team. The indoor units need drain line cleaning and airflow checks, also on a monthly basis. These are assigned to the junior technicians. The duct system requires insulation checks and damper function testing annually, handled by the HVAC supervisor. Lastly, the electrical panel should undergo terminal tightness and insulation tests annually, and this is the responsibility of the electrician. Following this maintenance schedule helps minimize breakdowns, ensure system efficiency, and extend equipment life. We have identified several key risks, classified them by type, and outlined the corresponding mitigation actions. First, we have equipment overload, which is categorized as an operational risk. To address this, we recommend load testing and phase balancing to ensure systems are not overburdened. Next is water leakage from IDUs, a technical risk. This can be mitigated by ensuring a proper drain slope and installing a flood switch to prevent overflow. Poor indoor air quality, or IAQ, is a health risk. Here, we suggest using FAHU, fresh air handling unit, integrated with CO2, carbon dioxide, gas sensor-based control to maintain safe air quality levels. Refrigerant leak falls under environmental risk. The right countermeasure is installing a leak detection sensor and keeping a recovery kit available to manage any spills. Lastly, we have untrained operator use, which is a human risk. The solution is straightforward: ensure through staff training and proper labeling of system and equipment. This structured risk assessment helps us ensure that each area of concern is backed by clear preventive actions, enhancing both safety and operational efficiency.
the discussion of our assignment is we already split into two columns, which is parameter and our goal. First one, temperature range. We already reached 22 until 25 degrees Celsius across all zones. The relative humidity is we already get 50 until 60%. Energy efficiency ratio, we get above 4.5 for BRF system. The downtime is we get below 1% annually. The IQ metric, we get below 1000 ppm, the carbon dioxide, and the PM 2.5 we get below 50. The occupant comfort survey, we get more than 90% satisfaction rate. So the discussion of our experiment, we already optimized refrigerant pipe routing for maintaining accessibility. We also enhance fire safety measure for penetration and ducts. We integrate drainage alarm system for indoor units. We also improve outdoor unit protection with passive cooling design. We upgrade ducts with acoustic and antibacterial cleaning. We implement zoning logic in BMS for target HVAC control. The last but not least is the conclusion of this assignment. We can simplify into 6 systems that we conclude in our assignment. First is smart investment. We centralize HVAC ensure comfort, energy efficiency, and air quality. Second one is professional design based on accurate load calculation, proportioning, and efficiency system selection. And the third one is seamless installation. Emphasize coordination across trades, noise control, and system accessibility. The fourth one, future-ready operation, real-time monitoring and control system support performance and energy saving. And then produce maintenance, predictive maintenance, reduce downtime and extend equipment life. The last one is long-term value, designed to meet involving standard, occupant expectation, and operating